Okay, so today I'm going to go over the practice for simplifying nth root radicals practice. So the first three problems say rewrite each expression in exponential form. So if you recall from our notes, the exponent that's with your radicand, the m in this case, is going to be the numerator of your exponent, and the index, which is in blue, will be the denominator of your exponent. Okay, so I labeled mine in the same colors. So when there's nothing there, that means it's a 1. So writing this in exponent form would be 17 to the 1/3 power. The next one would be k to the 3/4 power. And then the product 3m, and this would be a 2 since there's nothing there, square root is 2. So that would be 7/2. And if you wanted to write it, distribute it, you could write it as 3 to the 7/2, m to the 7/2, but not necessary. You can leave it with but you have to have the parentheses around it if you're not going to write it that way. So you couldn't write it like this. Okay, this wouldn't work because that would only be giving the 7/2 to the m and not to the 3. So that would not work. Okay, so 4 through 6 say rewrite each expression in radical form. So now we're going back the other way. Bottom number is your index of your radical, and top number is your exponent for your radicand. Sorry. So this would be square root of 2 to the 5th, and then we're supposed to simplify. So 2 to the 5th is equal to 32. And 32 is not a perfect square, but it has the perfect square factor of 16. So 16 times 2 is 32. Square root of 16 is 4. So our simplified answer would be 4 square root of 2, or 4 radical 2. Next one would be cubed root. Oh, sorry, we're supposed to simplify if necessary, so we're going to rewrite our improper fraction as a mixed number to help us simplify it in radical form. So 7/3 is equal to 2 1/3. So x to the 2 1/3 would be x squared, and then the cubed root of x.
Thanks to all for a wonderful day of testing.
Sorry about
Students,
this.
if you're in the building,
Give me a minute.
the buses are out front. It is time for dismissal. And if you are in the building elsewhere and are not supposed to be, please head out to your cars or to your sporting events. And everyone have a wonderful afternoon. Enjoy the sunshine. See you tomorrow. Go Jags.
Okay, sorry about that little announcement. All right, and then the next one would be 256x to the 1/4 would be a 4th root of 256x to the 1st, but we don't need to put that first there, so I'm just going to erase the first and my parentheses. And then the 256 is a perfect 4th, so the 4th root of 256 is 4. So I would get 4 4th root of x. All right, now we just get to a section with simplifying, and we've got numerical ones to simplify and monomial ones to simplify. So go ahead and get started here. First one, 108 is not a perfect cube, but it has the perfect cube factor of 27. So I can rewrite this to cubed root of 27 times 4. And then the cubed root of 27 is 3. So that would get out of the radical. So it would be 2 times 3 times cubed root of 4. So that would be 6 cubed root of 4. That is the simplified answer for 2 times the cubed root of 108. Okay, the next one, At first glance, I was like, you can't simplify this. What's going on? And then I thought about it that you could actually simplify it a little bit by remembering that at least you could get the negative out, because -1 is a perfect cube. So we could rewrite this as -1 times 2. And then the cubed root of -1 is -1. So that can get out of the radical. So we would have 6 times -1, and then the cubed root of 2. So -6 cubed root of 2. Number 9, 162 is not a perfect fourth, but it has a perfect fourth factor, 81. So this would be 2, and then we do fourth root of 81 times 2. The fourth root of 81 is 3, so we would have 2 times 3, and then fourth root of 2. So that would be 6, fourth root of 2. All right, now the next row has variables and numbers mixed together. So I'm going to do the variables, leave them in root form, but I'm going to leave the numbers in radical form, but I'm going to change everything with variables into exponent form because I think that's easier to simplify that way. So if I do this, the square root of 324 is actually a perfect square. Square root of 324 is 18. And then since this is a square root, remember that means its index is 2. So we would write these as our variables as a to the 3/2 power, b to the 7/2 power. And then if we rewrite those as mixed numbers, 3.5 is equal to 1.5 as a mixed number. 7/2 is equal to 3.5 as a mixed number. So then writing this into radical form would be 18a to the first, b cubed, and then this is the square root of ab. Now how did I get that? If you're a little bit confused, here's what I did. Here's a to the first. You don't have to put the 1 there, but you can. B to the third. So the big number of your mixed number is what is out of your radical. And then the numerator of your fractions tell you how many is inside. So you can put 1s there if you want, but you don't need to. And then the denominator is your index, which for square root, we don't have to put it there, but if you want to, you can. Okay? So there's what it would be like if we exactly followed the rule, but it looks kind of wacky. So I would just write it as 18a b cubed square root of ab. Okay? All right, next one. Cubed root of 216 m cubed n to the 6th. So actually all of these are perfect cubes. Watch this. Cubed root of 216 is 6. Cubed root of m cubed, some of you might be like, oh, that's m, and you're right. Cubed root of n6, oh, that's n squared, and you're right. If some of you are getting good at doing it in your head, that's fine. If not, then just write it out, m to the 3/3 n to the 6/3. Okay, that's just putting the index on the bottom when we make exponent form, and then the exponents of your radicand as the numerators. And then that simplifies to m to the first and n to the second. So that's what I mean when I said they're all perfect cubes. Everything gets out of the radical. There's no radical in our answer. Number 12. This one is not a perfect cube, but it has a perfect cube factor. And remember, you always want to get the negative out if you can. So you could write it as negative 27 times 3 or 27 times negative 3, but we want to get the negative out if we can, so we're going to write this as the cubed root of negative 27 times 3. And then write the variables in exponent form, so that would be p to the 2/3 and q to the 12/3. Okay? And then simplify. The cubed root of negative 27 is negative 3, and then you still have cubed root of 3 left. And then p to the 2/3, that's not an improper fraction, so we can't make that into, nothing's going to get out there. So that's just going to go back into radical form, cubed root of p squared. And then change the q to the 12/3. 12 divided by 3 is 4. So that's going to be q to the 4th. Now, that's wacky the way it looks right now, so we want to rearrange it and put the things outside the radical together, and then put the things that are inside the radical into one radical. So this would be negative 3 q to the 4th, and then the cubed root of 3p squared. So we put everything together under the radical, and we put the things that were outside together in front. Okay? All right, last row. So number 13, we've got variables, and I'm going to go ahead and change it from radical form to exponent form. So that's going to be w to the 4/4 and v to the 17/4. Now w to the 4/4, that's 1, so that's w to the 1st. And then v to the 17/4, if we write that as a mixed number, that's 4 and 1/4. So that means v to the 4th is getting out of the radical, and 1v, because of the numerator being 1 of our fraction part, 1b is going to stay inside. So we have wv to the 4th, and then 4th root of v to the 1st, which is just v. And again, I'll do it with here I'll do the colors just if you're still having trouble. So here's where your denominator of your fractional part goes. Here's where the numerator goes, but since it's a 1, we don't need to put it there. And then the whole number part of your mixed number is for the part of your variable that gets out of the radical. Okay? All right, number 14. The 4th root of 625. 625 is a perfect fourth. 5 to the 4th power is 625, so this is 5. And then c to the 23/4 in exponent form, and d to the 11/4. And then if you write those as mixed numbers, that would be 5 and 3/4 for c, and 2 and 3/4 for the d variable. So then remember, the whole number part is what's out of the radical. So that means we have c to the 5th, bring down your 5, and then we have c to the 5th outside of the radical, and we have d to the 2nd outside of the radical, and then inside the radical, it's an index of 4, it's a 4th root, and then we have c to the 3rd, and also d is also to the 3rd. And again, where I'm getting these numbers, they're the numerators of the fraction part of our exponents. And the part that's outside of the radical was the whole number part of our mixed number. Okay. Last one. We haven't done one like this, but this is really actually very easy. I just wanted to remind you guys that you would not do y plus 3 times y plus 3 times y plus 3 8 times. All you would do is think of that as like one thing to the 8th power. So just follow our rule of putting it into exponent form, and you'd have y plus 3 to the 8/4, and 8/4 simplifies to 2, so this would just be the binomial y plus 3 squared. And you can leave it like that. If you just are like, no, I can't do that, I don't like that, then you could distribute it and get the trinomial or the quadratic trinomial y squared plus 6y plus 9. But this is not necessary, okay? You can just leave it as y plus 3, the binomial squared. All right. Oh, not necessary to do this. So the answer I'm highlighting right now is fine, the binomial y plus 3 squared. All right, hopefully that helps. You can watch it again if you need to. And I will see you guys tomorrow.